This tutorial will explain XtremeData's backup utility. This backup utility is what we call a binary backup utility, and that means that it backs up all the binary files for the database. We are not doing a copy out function where we're creating ASCII files somewhere on the server where you could load them in bits and pieces and slices back into a specific table. This operates on a single DBX database server basis. Another thing to know about this backup utility is it occurs in parallel on all physical servers in the cluster, which is what makes it go so fast. It will be doing the uploading to object store in parallel as well. What this means is that the database server does need to be stopped before the backup occurs in order to maintain database coherency. So let's go ahead and we're going to follow through this procedure and execute a backup. One of the things that this backup utility will use is a configuration template. Now we can create one of those by doing the DBX backup gen. This is running on an Amazon cluster. I'm running as DBX DBA. We just created a sample configuration file. And in the sample configuration file, the parameters that you will need to know about in this particular case are the comments 1 and 2. You're going to want to modify those for whatever backup you're executing. Another thing that you want to specify is the server. Also down here in the object store, you need to specify an object store. It will be Oz in this case. And then you would need to get object credentials. And so in our specific case, we'll be running on Amazon Oz. You would create a bucket. That would be its bucket name, and then the credentials would be the access key, the secret key. If you were on Azure, you would create the storage account. That would be the account name. Within that, you would create a container. You would need to get the account key from Azure, and then you would need to create a shared access signature using this command shown below. And you can see up here is my existing backup to Amazon configuration file. Okay, we will verify that we have a server. Our server is Demo FinMarket server. And also, if we need to make sure that it's stopped. In this case, it is stopped because it doesn't have an asterisk next to it. So let's go ahead and perform the backup. The first thing it will do is it will create a summary screen. It does a whole bunch of checks. It shows you generally how big it is and then how much disk space you will need because it is effectively streaming it. You'll notice that the amount of disk space that we need doesn't come anywhere near the total DBX size on each of the physical nodes. And then the available disk space. All the permissions are checked to make sure that we have access to all the locations we've told it that it will need to work on. And if it comes up clear and says that the backup's ready to go, it will not bother to prompt you. It will go ahead and start backing up, and that's in fact what it's doing right now in the background. Other things that are happening here, we can see that it gave a very good summary. The number of physical nodes, we have 4 virtual nodes per physical node on this, total of 16 virtual nodes, and the object store bucket. In this case, we're using a subdirectory. You can create subdirectories in your backup environment, and in this case we just called it test88. Okay, the backup finished, and the first thing to note is this word in green here, success. That means that it sliced it up, backed it up to the object store bucket, and everything checked. All the sizes checked, all the slices went up. It took about 108 seconds in this case. You can see we went at about 1.7 terabytes per hour per node. Here's all the virtual nodes, what their original database size was, their backup size, compression ratio. And then we get down to the object store upload summary screen. We can see it gives the bucket, the directory, and the key element here is this is the name we're looking for. It is the server plus the name binary backup and then the date going all the way down to the minute. And we can see how many splits were created for each of the virtual instances and how many failed splits or how many upload retries. In this case, it was a perfect upload. So let's go ahead and take a look at our object store, and we can see that the 2220.03 backup occurred underneath the test88 subdirectory. And we can take a look at the files under there, and it always starts the same. Backup logs.tar, these are all the logs that were created during the backup are saved here. The backup stats, that's the JSON that will help us, basically describes the entire thing, help us recreate when we do the restore. Then we have all the data. This is the metadata on the head, and then all the virtual nodes have been sliced up. If we go off to our log location, which is specified inside the configuration file, it was specified to be here. And here are all the log files. The two main log files are down at the bottom. And that's a quick description of the DBX backup utility.